Yeah, hi everyone, Mr. Markwick here. Today's video I'm going to show you, actually the section I'm looking at in the textbook is sketching parabolas by completing the square. I'm not actually going to sketch parabolas today. In fact, I'm only going to be using the equation you see here in question 5 to determine the X-Intercepts. But you can actually go ahead and use these equations to work out the turning point or vertex and the y-intercept and go ahead and sketch it. But just for today's video, I'm going to go through and show you how to just work out the x-intercept, because I think that's probably one of the hardest skills when you're trying to sketch parabolas by completing the square. Before we start though, my class, we've looked at the quadratic equations when they come in standard form, so y equals ax squared plus bx plus c, and also the turning point form, so y equals a, x take h all squared plus k. And the turning point form, as it suggests, is really handy because you can actually just read off the turning point or the coordinates of the vertex off of the equation you've got there. So again, I'm not going to do that today. I'm going to go straight into working out the y-intercepts for... In fact, I'm going to go through all these questions today. So maybe if you're doing them in your textbook, for me, or for my class guys, it's page 451. Obviously, question 5, as you can see. Just skip forward to where you're struggling or the questions you think you need to double check. Anyway, let's get straight into it. Start with question 5a. So the equation is y equals x take 3 all squared, take 4. Again, to work out the x-intercepts, I'm going to let y equal 0. Okay, so 0 is equal to x take 3 all squared, take 4. Now at this point, it's already factorized somewhat, but I'm going to continue to factorize it using difference of perfect squares. Now, just for the sake of this first one, there are two terms here. That's one term and that's one term, and they're both separated by a minus sign or a subtraction sign. So I can factorize this further using difference of perfect squares. Okay, so in that case, I set up my two brackets. X take 3, which is the square root of x take 3 all squared, goes at the front end of both of those brackets. 2 goes at the back end of each of those brackets because 2 is the square root of 4. Okay, and in between those two terms inside the bracket, we have a plus and a minus. Right? At this point, I can go further because minus 3 and 2, or minus 3 and minus 2, are what we call like terms. They're both whole numbers, so I can go ahead and simplify that. So x take 3 plus 2 is x take 1, and x take 3 take 2 is x take 5. So from here, I can actually work out my x-intercepts using the null factor law. Okay, because if x take 1, that is, equals 0, or x take 5 equals 0, then x is equal to 1, or x is equal to 5. And my coordinates, I do need to give the coordinates of the x-intercepts. The actual answer there is, excuse me, so some room, is 1, 0, and 5, 0. Okay? Alright, the questions do differ, so let's just keep working through them. Let's move on to question B. Alright, so again, let's let y equals 0. And I've got here 0 equals x plus 4 all squared, take 9. Okay, again, I'm going to factorize using difference of perfect squares. 0 equals the front end of both brackets is the square root of x plus 4 all squared, which is just x plus 4. The back end is the square root of 9, which is 3. Separate by a plus and a minus. Collect those like terms inside the bracket, so the 4s and the 3s. X plus 7 and x plus 1. Okay, and I'm actually just going to go straight. I'm going to skip this part here and just tell you that the x-intercepts are minus 7, 0, and minus 1, 0. Okay? Alright, moving on to question C. Let's see if I can zoom out a little bit. Keeping those questions still in view. Good. Alright. Again, let y equal 0. I'm not going to write that in this time. Let's just put here 0 equals, you probably should guys, I'm just trying to make this video as short as possible so it doesn't take me forever to upload. So x take 3 all squared, take 36. Again, now factorising using difference of perfect squares. Set up my two brackets. X take 3 at the front end of both of those brackets. A square root of 36, which is 6 at the back end of those brackets. Separate by a plus and a minus. I've then got x plus 3. X take 9. And my x-intercepts as a set of coordinates are minus 3, 0 and positive 9, 0. Okay, now they're quite, believe it or not guys, they're actually quite easy questions when it comes to working out the x-intercepts. The next row of questions get a little bit trickier, so let's go ahead and have a go at question 5D again. Let's see, go through the whole process. So let y equal 0 and 0 equals 2, x plus 2 all squared. Now you can actually see I've got a value for a in those first three questions was equal to 1. I'm talking about the value here, or the coefficient of the bracket. So a in this case is 2, so it's not 1. Now what I actually need to do is I need to get rid of that value of a. I need to get rid of the 2. So what I'm going to do is I'm actually going to divide this side of the equation by 2. If I do that, I also need to divide this side of the equation by 2. Now 0 divided by 2 is just 0. In fact, let me get rid of that circle, it's just 0. And what you can see over here is that actually, again, I've got two terms on the right hand side of this equation, right? So, two terms. In fact, let's circle those. My pen's not working now. So, 2x plus 2 and 10 are the two terms on the right hand side. I actually want to divide both of those terms by 2. Alright, so 2 divided by 2 is just 1. Okay, a becomes 1 again. 10 divided by 2 is 5. So I'm now left with 1 in front of the brackets. We don't have to write that. X plus 2 all squared, take 5. Now I can go ahead and factorise difference of perfect squares. Notice this time though that the number here at the end is not actually a square number. In the first three questions it was. We were dealing with 4, 9 and 36. They're all square numbers, and the square root of those numbers will give us a whole number. The square root of 5 is not going to give us a whole number. 5 is not a square number, so we're actually going to keep it as a surd. We're going to keep it as root 5. Okay, and this becomes a little bit confusing for some people, but essentially it's the same process. Again, plus and minus in between. At this point, inside the brackets, the 2 plus root 5, or the 2 take root 5, we can't actually add those together. We can't add a whole number with a surd. So I'm just going to leave it like that. Okay, believe it or not. So if I was to go through the whole process again, it would tell me that if x plus 2 plus root 5 equals 0, or x plus 2 take root 5 equals 0, then x equals minus 2 take root 5, or x equals minus 2 plus root 5. Sometimes it's just written as minus 2 plus or minus root 5. I want to get you guys in the habit of actually writing a set of coordinates here, because in the test, my class will be doing a test. We'll actually be sketching these parabolas. So the coordinate of the x-intercepts are minus 2 take root 5 and 0, and minus 2 plus root 5 and 0. Don't worry too much about how to sketch that or find that location on the x-axis. We'll worry about that another day. At this point, we're just showing the calculations, how to work out the x-intercepts. Okay, moving on to question E. So again, E, let y equals 0. So 0 equals minus 3 take 1 all squared plus 30. Now I'm going to get rid of that minus 3, so I'm going to divide by minus 3 on both sides. Okay, I'm then left with should be take 10 there. So what do we got? So 0 equals x take 1 all squared take 10. It's the minus 3. Positive 30 divided by minus 3. It gives us minus 10. So we can do this one. And again, difference of perfect squares. We're going to use surds because 10 is not a square number. So x take 1 at the front plus root 10 take root 10. If I'm going to, again, skip all this stuff in between, it's just going to give me the set of coordinates of 1 minus root 10, 0, and 1 plus root 10, 0 as our x-intercepts. Okay, moving on to F. Flying through these guys, but again, you guys can pause the video at any point, rewind, watch, and see where you've gone wrong. So for F, again, let y equal 0. So we've got now 0 equals x take 5 all squared take 3. Now at the point straight away, we don't have to get rid of the value of a. We're going to factorize using difference of perfect squares. So x take 5 at the front of both brackets plus root 3 take root 3. Again, it's staying as a surd because 3 is not a square number. And from there, I'm just going to give you guys the coordinates of the x-intercepts, which will be 5 minus root 3, 0, and 5 plus root 3, 0. Okay, and again, to see how I've gone from here to here, you can refer back to the example I've got over here. It's the same process. I'm just skipping over these 2 steps for you guys because it's just the null factor law. Okay, and we've covered that previously. Alright, moving on again. I know I'm flying through a little bit, but like I said, there's lots of different types of questions here in question 5, so I'm trying to give you a good overall view of the different ways that you'll be asked to work out the x-intercept when viewing these. Now, for G, I've actually got y equals, in fact, let's let y equal 0, so 0 equals x minus 4 all squared. Now we actually, if we were looking at the turning point form here, there's no number at the end here for us, so there's no value of k, which means k is equal to 0. In that case, what we've actually just got here is perfect square. Alright, so if you remember back on my class in particular, when we were looking at working out x-intercepts of perfect squares, there is only actually one solution, because look at this. X take 4 all squared is the same as x take 4 times by x take 4. Now, if I was to use an null factor law, if x take 4 times by x take 4 equals 0, then either x take 4 equals 0 or x take 4 equals 0, which is going to give me 4 or 4, which is the same answer. So there's only one answer there. The x-intercept is 4, 0. Okay? So when you see an equation, I guess we could say that's in turning point form there. But there's no value of k. K is equal to 0. There is only one intercept. Alright? So the first 6 examples we did, if you look at those values, and maybe not this one, that one was a little bit different, but here, 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 and here, the values of k were all less than 0, and we ended up with 2 intercepts. So this is a good way to think of it. If k is less than 0, then there are 2 x-intercepts. If k is equal to 0, like it is in this question, okay, G, then there is only one x-intercept. And we know that parabolas can have 2, 1, or 0 x-intercepts. So I'm actually going to skip H for you and look at L, where k is actually equal to a number that's greater than 0. And when k is greater than 0, there are no x-intercepts. And the reason being is we can't actually factorize this using difference of perfect squares. So if I just say for I, let y equals 0, so 0 equals 2 times by x take 7 all squared plus 18. In fact, let's go ahead and just get rid of that 2, dividing by 2 on both sides. Okay. I then end up with 0 divided by 2 is still 0. Sorry, I should put 2 there in red. 0 equals x take 7 all squared plus 9. Now remember, when we're factorizing difference of perfect squares, there are 2 terms and they are separated by a minus sign. This is separated by a plus sign. So we can't factorize this any further using difference of perfect squares. Therefore, there are no x-intercepts. Okay, when we get to the point here that we've removed this value of a, okay, well, not removed it, but we've made it 1, and we've still got 2 terms separated, this time by a plus sign, there are no x-intercepts. Okay, so they're the 3 different, I guess, permutations of the turning point form. You know, when k is less than 0, so the 2 terms are separated by a minus sign, we know there's going to be 2 x-intercepts. When k isn't there at all, so k is equal to 0, there's just 1 x-intercept, it's a perfect square. And when k is greater than 0, so it's 2 terms separated by a plus sign, we can't factorize it any further using difference of perfect squares. It means there are no x-intercepts. And if I was to, I guess, draw this one for you, just so you can see what I mean by that, it's in turning point form, so I know straight away that the vertex here is positive 7, positive 9. So positive 7, positive 9, let's just say that's there. A is positive 1. A is a positive value, so it's opening upwards. Okay, it's not coming back down to touch the x-axis, is it? Okay, so that's why, I guess, visually, there are no x-intercepts for those ones. Okay, guys? And it might have been the other way around. It might have been the turning point was here, A is a negative value, and it's opening downwards. Alright, anyway, let's move on to the last 3 here. So, we've got J. Let's go ahead and write that one in. Again, let y equals 0. So 0 equals minus 2, x take 3, all squared, take 4. I'm going to get rid of that 2, so let's divide both sides by 2 here. In fact, let's divide by negative 2 to get rid of the negative. So that becomes 1. Negative 4 divided by negative 2 becomes what? Negative divided by negative is a positive. That becomes positive. So it actually becomes positive 2. So we're at the point 0 equals x take 3 all squared plus 2. Again, can we factorize this? K is greater than 1, therefore no x-intercepts. Okay, guys? Alright, moving on. K. Y equals 0. 0 equals, in this case, minus 1. Times by x take 2 all squared plus 5. Now we're going to get rid of that minus 1 first, so let's divide both sides by minus 1, minus 1. That removes the minus. This becomes minus 5, and that actually helps us out because now we can factorize using difference of perfect squares. Yes, we've got to use surds, but we can still do it. Okay, so 0 equals x take 2 at the front, x take 2 at the front, plus root 5 minus root 5. And again, using the null factor law, if x take 2 plus root 5 equals 0, or x take 2 take root 5 equals 0, then x equals positive 2 take root 5. So that's our first coordinate. 2 take root 5 and 0. Or the other coordinate is 2 plus root 5, 0. As a set of coordinates. All right, again, don't worry too much about finding this value on the x-axis. My guys will discuss that later. It's more about just actually finding the value of the x-intercepts. The last question I'm going to go through today, guys. I know this is a long video, but like I said, you don't have to watch the whole thing. Probably a bit late to say that, but just go ahead and watch what you need. Now, the last question there, that is an L. So again, let y equal 0 because we're working out the x-axis. The x-intercepts. 0 equals minus x take 3 all squared plus 10. Again, we're going to divide by minus 1 on both sides because we want to get rid of that value, that negative value of minus 1. So that's then gone. This becomes minus 10. I'm then left with 0 equals x take 3 all squared, take 10. Again, we can factorize that now because there's two terms there that are separated by a minus sign. So difference of perfect squares factorizing is okay. X take 3 at the front, root 10 at the back, separated by a plus and a minus. And I'm going to go ahead and straight and give you the x-intercepts. It will be 3 take root 10 and 0, or 3 plus root 10 and 0. Alright, so there you go, guys. Lots of different types of the same sort of question. Again, I wasn't actually sketching these for you. I'm more just showing you how to work out the x-intercept, which is probably the hardest part when you're looking at an equation in turning point form and asked to sketch it. Easy to determine where the turning point is. Obviously, it gives it to you. Pretty easy to work out the y-intercept because you can just substitute in x equals 0. Okay, when you're working out the y-intercepts. Alright, so just substitute in 0 for that one. If you're working out the y-intercepts, but to work out the x-intercepts, that's a little bit harder. That's why that was the purpose of this video, to show you how to answer all those different types of questions. One thing to remember though, like I said, is to look at the value of k. If it's less than 0, there's 2 intercepts. If it is 0, there's 1 intercept, it'll be a perfect square. And if it's greater than 0, so there's two terms separated by a plus sign, then we can't actually factorize it using difference of perfect squares. And it won't actually cross the x-axis. There'll be 0 x-intercept. So guys, hopefully that helps. And you can go over those questions and see what you did well and what you did wrong and where you sort of need to improve. Alright.